So a quick recap, just let's quickly recap whatever we had studied. Circle is nothing but a bounded figure which has no adjacent vertices, right? Okay, and what more in the circles? Circles have what is a unique property in a circle? Please tell me. All the points in the circle on the surface of the circle, on the curved surface of the circle, are equidistant from the center, correct? All the points on the curved surface of the circle are equidistant from the center of the circle. So the radii will always be equal, right, beta?
Yes.
Okay, mashallah. So what more did you discuss? What is the major thing that you're going to discuss in the ninth curriculum is about the chords, right? What is a chord in a circle? It is nothing but, please tell me the definition of a chord, Laiba. You need to repeat so that you can memorize everything in the class itself. And you don't have to study after the class. Please repeat. What is a chord, beta?
It is a line segment on the
Yes, joining the
endpoints
endpoints, or both of the endpoints are on the circle, right? They lie on the circle. So it's a line segment whose endpoints both lie on the circle. So which is the largest chord, beta?
Diameter.
Because why is it so? Because it passes through the
center
of the circle. Very good, very good. So what is the length of the diameter from the center? Is it 0? Yes, right? We had discussed it later on, right? The actual length or actual distance of a chord from the center of the circle in the diameter length is 0. Okay. Then what did we discuss in chord? Angle subtended by a chord at a point we have discussed. So in this the point R, PQ subtends angle at R. Which angle at R, beta? The chord PQ subtends which angle at R? Chord PQ subtends angle PRQ at R, right?
Yes.
Yes. What about what is chord PQ subtends at S? What is chord PQ subtends at the point S? Which angle does?
Angle PSQ.
Excellent. This is what we are going to study. The angles subtended by the equal chords are equal, right? The first theorem. Do you remember? Angles subtended by the equal chords are at the center of the circle are equal. This angle is equal to this angle. What is theorem number 2, beta? If the angles subtended are equal, then the chords are equal, correct?
Yeah.
Theorem number 1, equal chords of a circle subtend equal angles at the center. The vice versa or the converse of this theorem states that if the angles subtended at the center of the circle are equal, then the chords are said to be equal, correct? Theorem number 1, we have to prove theorem number 1. It is by the SSS postulate. That's all. The congruency you have to prove in two triangles. And then the theorem number 2 states that if angles subtended by the chords at the center of the circle are equal, then the chords are equal. Just this converse of the first theorem, right, beta? So which theorem did we apply? Yes rule, right? Which rule did we apply? Yes postulate, the same as the previous one. It was very easy, correct? Then we had discussed two problems. The two problems were same as the theorem 1 and 2, but instead of single circle, we have drawn two congruent circles. In two congruent circles, we have to draw two separate this one, but these chords should be equal. If these two chords are equal, then the angles subtended at this one are equal to same as theorem 1, and next one is same as theorem number 2. Okay, problem 1 and problem 2. So the next question here, Aliba, is next exercise here is about the perpendicular from the center of the chord. Okay, we had discussed two theorems here, Aliba. Do you remember what is it? If you draw a perpendicular from the center of the chord, what does it make, beta? From the center of the circle O to the chord AB, what does it make? Theorem number 1, what does it state, Aliba? Please tell me. Aliba? Are you there?
Yes.
What does it make? It's very important. It's very easy. It was very easy. A perpendicular drawn from the center of the circle to the chord. What does it do? We have told it. What does it do? It bisects the chord. It bisects the chord, right, beta? Do you remember what does it do? Perpendicular from the center of the circle to the chord actually bisects the chord. This is theorem number 3. Wasn't it very easy? If you draw chord, then if this OM is perpendicular drawn to AB, then what does it do is it bisects the chord. It's it divides this chord into two equal sides. That's all. Okay. Then if we see the next theorem, we have to prove the theorem. We have discussed the proof. What was the next theorem, beta? If the perpendicular is drawn from the center of the chord to this one, it bisects the chord. The converse of this theorem, how will you state? If a line bisects the chord into two equal things, then that line is actually perpendicular to the chord. Okay, correct? Just the opposite of the theorem number 3 you have to tell. Understood? Any doubts? Any doubts still here, Laba? No, right? Okay, this one proof was also there for the 4 theorems. All 4 theorems have the proof. Okay, you have to prove all the 4 theorems. The third thing that we're going to see is equal chords and their distance from the center. How do you calculate distance of AB from the center? Is nothing but we're going to draw a perpendicular, right? Okay. How would we draw how would you actually calculate the length, actual length from the point from the center of the circle to this chord AB? How will you calculate, Laiba? We'll just draw a perpendicular, and this is actual length, right? OM is actual length of AB from the center, correct? Actual distance of center O from AB is by calculating the perpendicular length, which I had discussed in this diagram, right? How will you calculate the point P from this chord, distance of point P from this chord, Laiba? Wasn't it based on this, based on PM, right? It was based on PM, right, Laiba?
Yes.
Okay, mashallah. So till here there were no doubts. And next we had about what is the distance of the diameter which is the longest chord from the center? What is the distance of diameter from the center? Is it not 0? Distance of diameter from center. Diameter lies on the center, so there is no distance from the center, correct? If there was a chord here, then then we'll draw a perpendicular, and then we'll say the distance of this chord AB from the center O is 2 centimeter, right? In this way, the line that is joining the perpendicular and the perpendicular drawn from the point O will actually give you the length of the chord from the center of the circle. Okay, distance of the chord from the center of the circle. So in that we have two major theorems. Okay, one major theorem states that equal chords of a circle equidistant from the center. Okay, if you have equal chords drawn on the circle, 2 centimeter, 2 centimeter, 2 centimeter, you have a point O, then all of it are equidistant, in an equal distance from the center. Equal distance matlab they will be actually in the same distance from center. समझ में आ रहा है, Laiba? Any doubts? You can please ask me. Okay,
No.
theorem 5 states that equal chords of a circle are equidistant from the center. For example, if you draw it in two congruent circles as well, if you draw two equal chords in this way, then you measure the distance from the center, it will be same because congruent circles are same, right? Okay.
Yes.
Then what about theorem number 6, which is just the converse of the theorem number 5? It is nothing but chords equidistant from the center of a circle are equal in length. Chords that are equidistant from the center of the circle, मतलब यहाँ से यहाँ तक अगर 2 centimeter होगा, यहाँ से यहाँ तक 2 centimeter होगा, तो these are equal in length. The chords which are equal in distance from the center of the circle O are equal in length. So AB is equal to CD. Is it theorem number 6? Understood? Any doubts still here?
No.
No. Can you say all of this theorem without saying 1 to 6? Give it a try, beta. Can you? Please give it a try. I'll just draw a circle. Just tell me what and all can be derived from this. Okay, I have a circle here. Well, I have a first theorem. Theorem number 1, beta. Please tell me the theorem number 1.
The equal chords of circles subtend equal angles.
Very good. Excellent. They subtend equal angles at the center. If you draw two chords that are equal, then you draw an angle to the center, then they actually subtend the equal angles. The second theorem, beta. Does the converse of it?
If the angles that subtend the chord at the center are equal, then the chords are also equal.
Very good. Excellent. Mashallah, barakallah. Okay, the third theorem. Isn't it about the perpendicular drawn? Yes, please tell me.
Yeah, the perpendicular of
Drawn from the center of the circle O.
center of the circle bisects the chord.
Very good. What about the next theorem, beta? It's just the converse. If something bisects the chord, if a line bisects the chord, yes, then it is actually,
it is
yes,
perpendicular.
yes, yes, very good. It's actually perpendicular, drawn from the center of the circle to that chord. It means we have to prove this one there, okay? That it is 90 degree. Very good. Next, what is the next fourth and fifth theorem, beta?
Equal chords of a circle are equidistant from the center.
Excellent. They are equidistant from the center. Very good. And what more? The last theorem, the theorem number 6.
The chords which are equidistant from the center are equal in length.
Very good, mashallah, barakallah fiki. So all of these were the theorem 1 to 6. Okay, mashallah. So you have all by hearted it, barakallah fiki. So this is a problem number 1. We had discussed problem number 1. Do you want me to start from 1, or we can go to the exercise problem directly?
We can go to the exercise.
We can do next exercise. Okay. So in the exercise number okay, this is that. See, okay, exercise 9.2. We have studied this problem. It is nothing but drawing the two circles and just finding out what does this chord length is. This chord length is actually, it is inside the circle. Here it is 3 centimeter. This circle has a 3 centimeter. This becomes 3 plus 3. Okay, it is actually the diameter of the circle. So this is chord length is AB. You can easily calculate whenever you're going to draw it on the circle. Okay, you just use the compass and draw the circle. You will get answer to this easily. Okay, chord length AB is equal to, you can measure it and write AB is equal to 6 centimeter. If you want to prove, you can just say that what is OA? OA is equal to this much. This is 3 centimeter. So this is also a radii. So this is 3. So this is 3. 3 plus 3 is 6. AB is equal to 6 centimeter. Done. This problem is quite easy. You just have to construct a circle of 5 centimeter radii and then leave 3 meters. There should be 4 centimeter distance between the radii of the circle. Okay, another circle should be drawn. It's given here. Okay, 4 centimeter. There should be distance of 4 centimeter from another. You have to keep point O here and draw another circle for 3 centimeter. Okay, radius should be 3 centimeter for another circle. That's all. Then you're going to draw the chords, and then you're going to see this chord that is drawn, how much length it is. Okay, can you take it as a homework? I want to see this in your book, notebook. Can you do it, beta?
Okay,
this is a homework for you. Okay, it's just taking the compass. Okay, keep it here on the O dash point and just draw one circle. Okay, this circle is a 5 centimeter radius. Just take it down if you have any doubts. Then draw a radius for this. If you've drawn this radius for the circle, then they have told that you have to be 4 centimeter apart from this. Take something 4 centimeter in length till here. Okay, यहाँ पे आप रखोगे और 3 centimeter का एक छोटा circle draw करोगे from this point. Okay. Okay, Laiba? Getting?
yes.
Okay, from this point you're going to calculate the 4 centimeter circle. After you draw the 4 centimeter circle, you can draw this chord that should be touching both of the circle here, A and B. It should touch both of the circles. Okay, that is given here. See here what they have given? Intersected 2 points. Okay, the distance between their centers, find the length of the common chord. They have told you the common chord. Common chord का मतलब क्या होता है? जो touch करता है both of the circles को. यहाँ you cannot have any other chord apart from this, because this point यहाँ पे touch करेगा, यहाँ पे touch करेगा for both of the circles. Correct? So you draw a chord here. Whenever you draw a chord in the circle, then it will be actually with the diameter of the circle. If you measure it using your scale, then it will be 6 centimeter in length. That's all is your answer. Fine. That will be AB is equal to 6 centimeter in length. Okay, beta? Any doubts?
No.
No. Please do this as a homework. Inshallah, this will be a homework problem for you. Okay? Chalo. So we will see the next problem. Laiba, come on, please read the question for me.
If two
Laiba, can you read the question?
chords of a circle intersect within the circle, prove that the segments of one chord are equal to corresponding segments of the other chord.
Yes, what we're going to prove here is prove that the segment of one chord are equal to the corresponding segments of the other chord. We have discussed what segments are, right, Laiba? What does segment mean? लाइबा सेगमेंट का मतलब क्या होता है? पार्ट ऑफ समथिंग, राइट? अगर ये ए बी दिया गया है हमारे पास, यहाँ पे सी है हमारे पास और यहाँ पे डी है, विच आर द सेगमेंट्स हियर लाइबा? AC is one segment, CD is one segment, DB is one segment, correct? Correct, Laiba?
Yes.
Yes. So if you have okay, they have given two equal chords, AB is equal to CD. Now what is given? Let's write it down, please. What is given? What do we have? AB is equal to CD, right, beta?
Yes.
AB and CD are two equal chords. We're going to construct the circle. We'll draw AB and CD as two equal chords. Then prove that the segments of one chord. First, they have told two equal chords of the circle intersect each other. They are intersecting at this point E. Okay, they have told you the segments of one of the chord are equal to the corresponding segments of other chords. So what are you going to prove is AE is equal to ED and CE is equal to EB. Okay, what is to prove?
AE
What are
is
the
equal
two
to
segments
ED.
formed by this and this chord? ये कट करेंगे तो यहाँ पे इंटरसेक्ट करेंगे तो ये दो एक सेगमेंट बन जाएंगे, ये दो एक सेगमेंट बन जाएंगे. सो वी हैव टू प्रूव AE is equal to ED and CE is equal to EB. Understood? Have you understood how to construct this? Yes, right? It is easy, quite easy. पहले ये construct करोगे, फिर ये construct करोगे. These are the separate constructions. Why are we taking this? Is because we have theorem 5 and 6. Do you remember what theorem 5 and 6 states? Whenever you draw something, theorem 3 and 4, it states that whenever you draw a perpendicular, then it bisects it, right? Bisects it. That principle we are going to take now. Okay? Let's start proving. Chalo. We have just written what is given and what is to be proved, and what we need to construct. What extra things that we are constructing? Better extra construction. We have to draw OM perpendicular to AB, correct? Then
Yeah.
ON perpendicular to CD. Okay, then we are just joining OE. Okay, we do not have to, but let's join OE. We'll see why we are using this OE kind of concept here. Okay, chalo. This is everything given to prove and the construction done. Now we'll quickly start with the proof. Okay, we'll see if we have some space here. Okay, we do not have. Are you writing all of this in the book?
Yeah.
Please write it down. I'm gonna clear the screen now. So this is the construction. Proof is very easy and it's quite easy. Okay, can we just begin? Are you done writing? Okay,
No.
please write. Do you know why we constructing OM is perpendicular to AB and ON perpendicular to CD? Because we need that AM is equal to MB, because so that we can prove that A is equal to ED and something like this, correct? We need these two things. And we need CN is equal to ND. So we are constructing something like this, and then even this is also required because we have proved the congruency. We want the small parts as well, correct? We want the small parts, EN, ME, all the segments we need now. So we are going to construct all of these three things. Okay, and one more, what is it? Join OE is also construction, correct? These three are constructions to prove A is equal to ED, C is equal to EB, and then construction is this thing. Given AB is equal to CD, correct? Okay, we are done?
Yeah.
Are we done, Laiba?
Yes.
Yes, okay. Let's quickly see the proof. How will we start with? We just constructed something, right? What did we construct? This and this. So let me not can we not take AM is equal to MB and CN is equal to ND, beta? Yes, is it right?
Yes.
AM is equal to MB, correct? Is it right? AM is equal to MB? Yes, correct?
Yes. Yeah.
And then CN is equal to ND. Okay, but do we not have AB is equal to CD? Do we not have AB is equal to CD?
Yeah.
Yes, we also have, but AB is equal to CD is given. Why is this? This is because of theorem number, which theorem, beta? Please tell me, theorem number 3, right? If a perpendicular bisects the, if the perpendicular is drawn, then it bisects the chords, correct? Yes. AB is equal to CD we already have. Can we not write, instead of A, can we not write, see here, AM is equal to ND and CN is equal to MB? Can we not write this, beta? Just check whether we can write or not. Yes, because AB is equal to CD. This and this we can prove equal. This and this we can prove equal. Correct? Because both this and this line are equal. So we'll write this is equal to this. This is equal to it, just for the proof of the segments. Correct? We are going to swap the segments and prove, right? So to prove, swap the segments and prove, we are just taking this down. Please take this down as well. Let's consider this equation 1 and this is equation 2. This much is actually done. Now the theorem is very simple. We are going to prove the congruency in these two triangles, and then we are directly going to prove. Please consider this equation 1 and 2. Please write it down. Have you written? Done, Laiba?
Yes.
Okay, mashallah. So we have taken AM is equal to ND as equation number 1, and MB is equal to CN, right? CN as equation number 2. Let's keep it aside, okay? This is actually required. Now let's consider two triangles, okay? Which triangles are we going to consider, beta? So that we can prove the small points as well, okay? ME and EN. If we consider these two small points is equal, then we will have so many things to prove, okay? So let's consider two triangles. Which triangle do we have here, beta? Please tell me triangle names. OME and which one, beta? Yes. These are the two triangles. Yes, Laiba. Then how can we prove the congruency? Let's please tell me, how will you prove the triangles? Congruency in these two triangles. Is OM angle OM is equal to ONE? Yes. OM T is equal to angle ONE, which is equal to what, beta? 90 degree, right?
90 degree.
One is done. This is done. What is the next thing, beta? Is it not OE is equal to common? Yes, very good. OE are common. What more thing can we do from this bit? What can we derive from this? There's one more thing that we can derive.
Side OM is equal to ON.
Yes, why is it so? Please tell me. OM is equal to ON. Is it not due to one theorem? Which theorem? Please tell me, which theorem is it? Equal chords subtend. Equal chords are equidistant from the center. Is it not right? Which theorem? Is it not theorem 5?
Yeah.
Equal chords are equidistant from the center. OM is equal to ON. So OM is equal to ON. So we have three things. Which three things, beta? Yes. A. Yes. One side, one angle, one side. Or we can, if there is something like called a 90 degree, do you know we had proved one theorem, that is RHS theorem. What was it? Right angle, one side, and one hypotenuse. Do you remember this?
Yes.
RHS theorem. RHS postulate. This was in the triangles. See, all of these are interlinking each other, right? All of these, the quadrilateral chapter, the triangles chapter, as well as the circles chapter, need the theorems, correct? Theorems of each other. Especially these postulates are very important. Yes, ASA, and more, right? RHS postulate more. So you can also write SAS postulate here, or you can write RHS postulate, okay? No problem. It's better if you write RHS postulate, because right angle, hypotenuse, and a side. So we have got one right angle here, correct? This is an hypotenuse, and one side here, this one, correct? So what do we prove after this, beta? What after applying this postulate, what do we say? Can we not say these two triangles are congruent?
Yes.
I cannot hear you. Everything fine?
Yes,
okay.
Okay.
Triangle OME is congruent to OEN. Because, why is it so? Because RHS or SAS congruency. Okay? You can write whichever you remember. at that moment of time in your exam. Okay, so if this and this are congruent, what only thing that we had to prove was m is equal to en. For to prove this, we are going to see the congruency. ठीक है, we just had to prove m is equal to en. समझ में आ रहा है बेटा? इसके लिए हमने इतना सब किया था, कॉन्ग्रुएंसी प्रूव किया था. ठीक है, ठीक.
Yes.
Okay, from this, so m is equal to, please write all of this down. I'm going to clear the screen now. Yeah, m is equal to en. Why is it so? M is equal to en because of CPCT, right? In two triangles, corresponding parts of the congruent triangles. Please write it down. Is it done?
No.
Okay. Have you understood? 3m5. Why theorem 5 is used? Theorem 5 because equal chords subtend are equal chords are equidistant from the center of the circle. Okay. M is equal to en. Oh, triangle, both of the triangles are congruent because of SAS congruency or RHS congruency rule. So m is equal to en by the CPCT. So we just have equation 1 and equation 2. You're going to apply m is equal to en and see what the result is. How we are going to apply is we are just going to add 1 and 2, 1 and 3, and then 1 and 3. Yes, 1 and 3. Let's see how we'll see this. So are you done?
Yes.
Yes. So let me just erase all of it. Do you remember equation 1? Let's keep m is equal to en as equation number 3. Okay? Let's keep it equation number 3. Like, do you remember equation 1 is am is equal to nd? Equation 2 is mb is equal to cn. So how can we do some simplification in 1, 2, and 3 so that we can get am is equal to nd, a is equal to ed, and c is equal to eb? How can we do this, Beta? Okay, if we add equation 1 and 3, just check. If we add equation 1 and 3, can we get something from that? Let's add equation 1 and 3. Where is equation 1? am plus me is equal to en plus nd. Okay? What is am plus me, beta?
AE.
Very good. Is equal to, what is en plus nd? En plus nd.
END.
It is ed. Total line. You just tell this one and this one, right? Final points. Is it ed?
Yes.
Yes. So have you proved the first thing? AE is equal to ed. Done, right?
Yes.
Yes. First proof is done. Let's see equation 1 and equation 1 and, sorry, let's see equation 2 and equation 3. Let's add equation 1 and 3. Add equation 1 and 3. Here we have added equation 1 and 3. Let's add equation 2 and 3. Where is 2? mb plus me. How are we going to add? Do you remember how to add? We have to add left hand side with each other and right hand side with each other. Do you remember this?
Yes.
mb plus en, mb plus me, and en plus cn. Now please tell me, what is this? What is mb plus me and en plus cn? Okay, mb plus me cannot work out. mb minus me, let's subtract. Okay, 2 minus 3. We just have to get ce, right? Right, beta?
Yes.
Let's subtract 2 and 3. So mb minus me. Correct. This way we have to do it. This is the right way. It's very easy. Please tell me, what is mb minus me? mb line से आप me को निकालोगे तो आपको क्या मिलेगा? Just eb, right? This is a mb line, beta. You're going to remove me from that. You just have what left out? eb, correct?
Yes.
Library cannot hear you. Okay. Then you have En minus Cn. Where is En here? This is En minus total Cn. मतलब total Cn से अगर आप En को subtract करोगे तो आपको क्या मिलेगा? Cn minus En. Okay, this is equation 2 and this is equation 3. Okay. What is Cn minus En? Cn minus En gives you just Ec. Okay. Write it down. Write it down. We have proved these two things. You'll understand it. Just write 1 and 3, add 2 and 3, subtract. I want you to see you to see in your rough book. Write the answer in your rough book. Did you understand this? Did you understand this, Laiba? Any doubts here? What did we just do? 1 equation 2 equation 2 equation 3. What was equation 3? Is it not M E is equal to En? Yes, this was equation 3. What we did at first was 1 and 3. We had just considered equation 1 and 3 and then added 1 and 3. 2 and 3, we just subtracted 2 and 3 so that we can get the segments. That's all. Write it down, Vita, please. Was it easy?
Yes.
Laiba, can you please tell me the entire procedure? Have you written it all?
No, I'm writing.
Please write it down and tell me entire from the start. How did we start with and how did we end? We just wanted M is equal to En, so we proved the congruency, right?
Yes.
Yes. M is equal to En is done. We are just playing with the equations here. We are going to add something, subtract something, and we are going to create the segments. That's all. We're going to extract the segments out of each. Done with this? Please tell me when you're done, okay? Laiba, do you need the recordings of our lectures? Yes, beta?
We subtracted MB and ME, right?
Yes, we are subtracting MB minus ME. This total, from this total, we are subtracting ME. What we will get? We'll just get the remaining EB. Correct?
Yes.
Then we are subtracting En minus Cn. Sorry, Cn minus En, beta. It's not En minus Cn. Cn. This is equation 2, right? First we'll keep equation 2, then equation 3. So we are going 2 minus 3. So Cn minus En. What is the Cn? This is total Cn. From that, En is subtracted. So we'll just have the remaining Ce there. Correct?
Yes.
EC. So this is proved. Correct? Check what we have to prove. Isn't it proved? Done?
Yes.
Okay, mashallah. So can you please tell me what and all we did here, beta, from the start? पहले हमने क्या किया? हमने perpendicular लिया था, इसने bisect किया. We have told this have bisect this. So they divided into equal halves. We created AM is equal to this one, correct? And MB is equal to NC, correct?
Yes.
We took it as equation 1 and equation 2. Then we just wanted this one and this one equal. We took third equation. Then we are just playing with the equations. 1 plus 3 we did, and then 2 minus 3 we did. Right? Nothing extra in this. Only 3 equations you have to form. For the third equation to form, we just had to prove the congruency, correct? So now, doubts or no doubts? Any doubts here, beta?
No.
No, mashallah. So we'll just see the next question. The third question. If two chords of a circle intersect within the circle, prove that the line joining the points of the intersection to the center makes equal angles with the chords. What the question they have asked is if two equal chords of a circle intersect within the circle. Okay. But actually they won't give you the diagrams, beta. So please learn to draw the diagrams. I'll tell you how you're going to draw this, okay? If you have a circle, fine, beta?
Yes.
Okay, this is your circle. Tell me the question. Read out the question for me.
If
they have told you that there are two equal chords, okay? They are intersecting the circle. Come on. We are having one chord. We are having another chord. They are somewhere intersecting the circle. They should actually be equal, correct? So I think this is wrong. This would be a wrong diagram if I tell. Okay. Let's just take That's again. Let's just take the same to this one. Okay. They are intersecting at a point, some point. Okay. Then what if prove that the line joining the point of intersection to the center, line joining from the point of intersection to the center. Which is the point of intersection? Can you please tell me, Laiba, where is the point of intersection now? If I name this point as E, if this is A and this is B and this is C and this is D. Which is the point of intersection? Intersection का मतलब क्या होता है? जहां दो chords meet करते हैं, correct? So which is that point, beta? Is it not E? Yes. So इन्होंने पूछा है prove that the line joining the point of intersection to the center makes equal angles with the chords. तो इन्होंने पूछा है अगर आप line join करोगे OE को OE के लिए, तो this will create equal angles to the center, equal angles with the chord. What they have told you is you have to prove that the angles made by them is equal. Which angles made by them are equal? Agar, okay. We'll draw one construction, this perpendiculars. We are going to prove this and this angles are equal. Correct, beta? Which angles we want? This angle should be equal to this angle. We have to prove. That's all. How to prove? Just we have to make two triangles. Is it easy? Very easy. You have to make two triangles, prove the congruency, and that's all. Will you do it? This problem is so easy. Can you do it for me? Come on, give it a try. First, let's tell me what to prove. The figure is here. Just tell me what to prove. Angle. Which angle, beta? Is it not angle MEQ? MEQ is equal to angle
NEQ.
Okay. Can we not write the whole angle here instead of small angles? Let's write BEQ is equal to QEM. Okay, because bigger will be better, right?
Yes.
Okay. छोटा छोटा लिखने से better है कि बड़ा लिख लोगे. Okay. Let's instead of that write BEQ is equal to QNC. This we have to prove, right? This angle and this angle should be equal. That's all, right, beta?
Yes.
Chalo. How will you prove this? You just have to consider small triangles. Smaller angles. हमने first smaller angles का prove करना है. Then we will write that it is equal to that angle. Correct? We'll just prove for the smaller angles. Then we'll see the other things. So what is given, beta? Please tell me what is given. They have told you that. Okay. Prove the line joining the point of intersection to the center makes equal angles with the chords. Center within the. Okay. Okay. How to prove? Have we not drawn something called diameter here? Yes, right? Why have we drawn this? Because they have told that it is intersecting. Correct? Something is intersecting from the center of the circle. Then what we have to prove, this is given that chords are equal. What chords are equal? Chords? Correct? Chords are equal. AB and CD are equal. Then what to? Let's start with the proof. And what construction did we do? Is it not based on theorem number 6, 3, 4, 5, 6? Yes. To just include theorem 3, 4, 5, 6, we are doing one construction. What is this construction, beta? OM and OM are drawn perpendicular to AB and DC, correct? Let's start with the proof directly. You can also write construction here. Please write the construction in your exam or the test whenever you are writing. You have to write a construction. What? Two perpendiculars are drawn, correct? Which are this? Which is it, beta? OM is perpendicular to AB and ON is perpendicular to DC. Is it not?
Yes.
Yes. So let's start with the proof. What are we going to do now? Consider the triangles. Which triangles are we going to consider? I told you it's just the congruency. Two triangles we are going to consider. Which two triangles, beta? OME. Alavi, do you want the recordings of this lecture to hear again? If you want, I can give you the link, inshallah. Okay. OME and triangle ONE. Okay? We have to prove the congruency in triangle OME and ONE. Aliva, you're going to do it for me. Chalo, how will you prove this? It's quite and very easy. Aliva, please tell. How will you prove the congruency here? We have two triangles. Should I maximize the screen? Have you written it all?
Yes.
Okay, come on, tell me. In two triangles, OME and ONE, which points will you consider? First one. Shuru karo beta.
Angle OME is equals to angle ONE.
Excellent. OM is equal to ONE. Why is it so,
90
beta?
degree.
ONE, which is equal to 90 degree. Excellent. This is perpendicular already given. Second thing. And no angles are here. Okay, second thing. Something is common. Please tell.
OE is equals to OE.
OE. So it is common. Okay, very good. And what else, beta? There is one more thing that is left out. It was same in the previous one. We are going to apply one theorem there. Yes. Come on. What is equal to what?
OM is equals to ON.
Yes, excellent. Why is it so, beta? OM is equal to ON. Why is it so?
Because of
Equal chords?
Theorem 5.
Equal chords? Equidistant from? Equal distance from center. Very good. Equal chords are at equidistant from center. Equal distances from the center. Very good. So which postulate do we apply here, beta? One side, that is 90 degree, one side, one angle, one side, one hypotenuse on one side. We can apply RHS congruency or SAS postulate, side angle, side postulate. It's better if you write RHS congruency, okay? So from the Lagrange congruency, we have proved that MEO is equal to EON. Done. CPCT. MEO is equal to OEN, correct? These two angles are equal. If those two smaller angles equal, small ka matlab yehi hota hai, right? This and this are equal. So this is whole, right? So which is equal to BEQ is equal to CEQ, correct? Please write it down. Have you written it all?
Yeah.
Yes, mashallah. So this is equal. Done. This is your answer. Okay. Any doubts on this? It was very easy, correct?
Yes. How did we get BEQ equals to QN? See.
BEQ, but I'll tell you. Wait. I'll just tell you. Don't you think if you write a small line this way and you extend this line and this line here, I'll tell you. If you have a point here, A, O, B, and C, O, D, don't you think they both have same angle?
Yes.
Yes, right? AOB is same as COB because they are on the same point and the same lines. Just they're extended. This line is extended to CD and this is extended to this. It's understood without any doubt. Okay. So we don't have to prove that. You don't have to prove that. So MEO, you just are going to prove MEO is equal to OEN. If you prove MEO is equal to OEN, instead of the smaller line, we are just drawing this, extending this line. That's all. So this is equal to this. Correct. Actually, you have to prove ME is equal to OEN. That's all. But why are we considering this? Because they have told you that joining the full whole center, from the center agar ye join karoge to, it is better if you write BEQ is equal to QEN. Correct? Yes. If you do not write this, no problem. This is correct answer for you. Okay. This much is also correct answer. For the betterment, यहाँ से अगर लिया है हमने chord तो chord भी आ जाएगा साथ में, correct? Angle के लिए, angle दिखाने के लिए, correct? The whole chord भी आ जाएगा full angle दिखाने के लिए, right? Understood, Laiba? Any doubts?
Yes.
No, this was quite easy, mashallah. Next one, this is also so easy, beta. If a line intersects two concentric circles with the same center, with center O, A, B, C, and D, at A, B, C, and D, prove that AB is equal to CD. How will you prove AB is equal to CD? Chalo. AB is equal to CD prove करना होगा. किस तरह prove करोगे आप? Any guesses? Any guesses? Can we not take the theorem number 3? 3 is always there. 3 is very important. Why is 3 important? Because we can get is equal to that sign, right? Equal to sign जब भी यहाँ पे इस तरह आएगा question, आपको theorem number 3 consider करना होगा. Theorem number 3 क्या है? Perpendicular drawn from the center of the circle to the chord bisects the chord, correct?
Yes.
Bisect का मतलब क्या होता है बेटा? It divides it into equal halves, right? So Let's draw a perpendicular OM. Fine. Liba, draw a perpendicular OM to AB or AD same, right? Both lines are same. AB or AD. Okay. So the first thing, OM क्या करेगा बेटा? Does it bisect both of it? Yes. OM bisects. We have from the theorem 3, right? OM bisects AB, AD also, and OM bisects दो chords है यहाँ पे, right? BC also. So AD का क्या बनेगा बेटा? AM is equal to MD, correct? Laiba?
Yes.
AM is equal to MD बनेगा. Sorry, AB का नहीं, AD का AM is equal to MD बनेगा, and BC का BM is equal to MC, right? BM is equal to MC. Can we not consider equation 1 and equation 2?
Yes.
Let's just minus 1 and 2. Subtract 1 and 2, please. Tell me what is the answer. AM minus BM is equal to MD minus MC. AM minus BM करो, क्या मिलेगा आपको? Please tell me. AM, this one whole, इसमें से BM निकालोगे तो क्या बचा रहेगा बेटा? Is it not AB?
AB.
Yes. MD minus MC. Please tell me. यहाँ पे एक construction है, okay? You have to construct this one, okay? What is MD minus MC? CD. Done. Proved. Was it easy?
Yes.
Damn easy, right? So please write it down. What? Just you have to write all of it, okay? To prove. What is to prove? To prove. This is given in the question. AB is equal to CD. Okay. Then what is the construction? Construction. Only single construction you have to do. What is single construction that you're going to do? OM perpendicular to AB, right? AB, no, AB, AD, right? The whole thing, AD. OM perpendicular to AD is a construction. This is a proof, okay? This is a construction. Draw a triangle, draw perpendicular OM to AB and AD. This is the proof. OM bisects AD, so AM is equal to MD. OM bisects BC, so BM is equal to MC. What is the theorem, beta? Do you remember which theorem? Theorem number 3, right?
3.
What does it say? When a perpendicular is drawn to the chord, then it divides the chords into two equal, it bisects the chord, that's all. So theorem number 3, equation 1 and equation 2, theorem number 3. So 1 minus 2 gives you AB is equal to CD. Was the same principle used in problem number 2? Do you remember?
Yes.
Yes. There, we just put the congruency because we wanted something else. One more point. We just did, then we did games with 1, 2, and 3, equation 1, 2, and 3. Okay. You just have to do some games with 1, 2, and 3 equation so that you will get the right answer. Okay. Are we done?
Yes.
Okay, mashallah. So I'll just start with the next problem. The 6th problem I'll give you as a homework because it is same as the 3rd, this problem. Okay. Just a bit. Okay, are you done with the previous ones? Any doubts in previous things? Laiba, any doubts, Peter? Laiba, I cannot hear you.
No.
No doubts, right? Okay, mashallah. So, where is the next question? Okay, this is the next question. Oh, please read out for me. Laiba, please read out for me.
3 girls.
Yes, beta, 3 girls. Okay, let's write Reshma is here. Okay, this is Reshma.
Salma and Mandeep are playing a game by standing on a circle of radius 5 meters drawn in a ball.
Mandeep. See, the radius is 5 meters, beta. Okay, so AM is 5 meters. This is 5 meters. This is 5
Reshma throws a ball to Salma, Salma to Mandeep, Mandeep to Reshma. If the distance between Reshma and Salma and between Salma and Mandeep is 6 meters each, what is the distance between Reshma and Mandeep?
Reshma and Mandeep. So what distance do we need here, beta? This is not 5 meters. Just a second. This is not the radius, correct? This is the radius. यहाँ पे AO is the radius. 5 meters is given. ठीक है? Now it's all fine. Okay, Laiba. यहाँ पे मुझे बताओ हमने क्या क्या कंसिडर किया है. हमने एक सर्कल ड्रॉ किया, ठीक है? First, Then they have told there is Reshma here, this is Salma here, and there is Mandeep here. Okay? If we draw it, they're standing at an equal distance from each other, correct? Or ek beach, they have just sent 6 meters, right? There is a difference of 6 meters between each,
Yes.
correct? Now we have to calculate this total distance. What is this? Reshma to Mandeep, correct? But the center is somewhere else. Some center यहाँ पे रहेगा. Center to अगर हमने यहाँ पे draw किया था, अगर यहाँ पे draw करोगे तो इसका radius मिलेगा, correct हमें? So its radius they have told is 5 meters. This is radius 5 meters. So this is the diagram. Diagram understood? It's quite easy, correct?
Yeah.
So diagram understood. मैं इसको erase कर दूंगी. We'll just move to the problem. Okay. What we are going to just calculate here is beta AM and MC. That's all. AM और MC को calculate करेंगे. AM plus MC करके दिखाएंगे. That's all, right? How will we prove this? Laiba, can you please tell me? AM and MC. Okay, AM का हमें पता नहीं है, but we know AO, right?
Yes.
Yes. So, like, can we not write AM as just the? Okay, let's just write it as. Let's write what is given and then we'll go to the proof. So what is given? AB is equal to 6 meter. BC is equal to 6 meter or some centimeters. Meter is just meter, yes. Okay. Then we know the radius of the circle. OA is equal to 5 meters. And what else did we construct here? AM and MC. Why did we consider AM and MC? Because A to C we need, right? Distance. Then we have actually considered a perpendicular OB, right? This OB is also 6 centimeter, beta. It's 5 meter. Do you remember? OB is 5 meter. Why is it so? It is a radius, right?
Yes.
Yes. So that is also 5 meter. OB is equal to 5 meter. One extra thing we are drawing, we draw a perpendicular BM, correct? BM perpendicular to AC. This we are drawing here. BM perpendicular to AC. Okay, because we need AC. Something called AC there, okay? We'll just remove everything else. Okay, AC. So OM is also drawn here. OM is fine. Okay. Can we not see this as an isosceles triangle, beta? Just see the triangle AOB. Yes?
Yes.
Yes. We have 5 centimeter here, 5 meter here. This is a 6 meter. We'll see, if you see the triangle AOB, then it is isosceles triangle. Okay, just for the curiosity. We also can apply actually the midpoint theorems here. We also actually can apply midpoint theorems. How can we apply midpoint theorem? Do you consider this? Can you see this? How we can apply a midpoint theorem for this?
Yes.
If this is 5, this is 5. If we apply something like this, we can also apply a midpoint theorem. But that's actually not required, okay? Okay. Okay. This much is enough. Have you written this down, what is given, please? We'll just go directly for the proof. We do not want to go in depth for this. Is it done? Have you written all of this down, beta?
Yes.
Okay, mashallah. So let's directly see what proof we can apply here, okay? Now, let's consider AM equals to Y and MC is equal to, because AM and MC are equal, so we do not have this one. AM and MC is equal to Y. Let's just consider AM is equal to MC. Do you know AM is equal to MC? How can we say AM is equal to MC, beta? Is it not the perpendicular drawn to something that is chord? This AC is also a chord, right? So it bisects the chord. So AM is equal to MC. You do not have to find MC now. You just have to find AM. So chalo hum just AM find karenge. We are going to find AM now. Let's consider it as Y. And we do not know OM also. Let's consider this as a X. Let's consider this as a Y. We just know this one is 5. And this one is 6. And this one is 6. Okay. So AM is equal to Y. What we'll write for the OM? OM is equal to X. And what about for the BO, for the whole? What is BO? Is it not the radius? Is it not the radius? Is it not 5? Yes, right? Whole BO, OB. OB is 5. It is the radius of the circle. So what is BM now? Just the BM. Please tell me what is just the BM. BO is 5 beta, okay?
Yes.
What OM is X. What is BM now? Isn't BM 5 minus X?
Yes.
Yes, right? Whole 5 में से अगर x निकालोगे तो आपको bm मिल जाएगा. So these are the small points you are going to write now. Okay, write it down somewhere. am is equal to x. Let's write am is equal to x. Sorry, let's consider am is equal to y. Let this be x, and this is, we know this is the 5 centimeter, and let's just consider this as a 5 minus x. So whatever is not given, let's write it in this way. Okay, done? Have you written it all?
Yes.
am is equal to y, om is equal to x, and bm is equal to, we are just considering these triangles because this will be actually be equal to this, right? So we just consider all of this diagram, and we'll just go x and y. What is x, what is y? That's all. Okay, it's quite easy now. Is it done till here?
Yes.
Understood. Chalo, we'll just write x, y yahan pe. This is 5, right? This is 5 minus x, and this is 6, and this is 6. Now let's just consider triangle AOM. Ab triangle AOM mein, can we not apply the Pythagoras theorem, beta? Is it? It's a right angle, right? What is the Pythagoras theorem? Please tell me the Pythagoras theorem. Hypotenuse square is equal to, correct? Other side squares. What is Pythagoras theorem, beta? If this is a right angle, Laiba, this is hypotenuse, right?
Yes.
Hypotenuse. The squaring of hypotenuse, if this is A side and B side, is equal to A square plus B square. Okay? If you write this as C square is equal to A square plus B square. This is actually the Pythagoras theorem, which you had studied very long back. I think in the 6th grade you have studied this. Okay?
Yes.
So, beta, please apply Pythagoras theorem to this. How will you apply? Is it not AO square is equal to AM square plus MO square?
AM square, yes.
Yes. This is for this triangle. For the triangle, how will you apply? एक और triangle के लिए how will you apply? AB square is equal to AM square plus MB square, correct?
MB square, yes.
Yes. Now इसमें आप fill up कीजिएगा please. AO square के लिए क्या लिखोगे आप? 5 square, right? What is MA? Is it not Y? Y square. What is MD? Where is MD? Sorry, it's MO. What is MO? Is it X? X square. X square plus Y square is equal to 5 square. Just let this be equation 1. And for this one, AB square. What did we write, beta? Please tell AB square के लिए हमने क्या लिखा था? 6 square, right? AB 6 na. What is AM? AM is Y again. AM square is equal to Y square. Plus, what is MB now? MB is 5 minus X, correct? Whole square. What is A minus B whole square? Do you know the identities? A minus B whole square is equal to A square minus 2AB plus B square. Can we just split this out? 6 square is equal to Y square plus, how will you write this? 5 square. Yes, minus 2 into 5. 2 into 5 into X. What is it? 10X plus X square. Okay? Is it correct?
Yes.
Yes. Chalo. Okay. Let's have this here and let's have this here. Or let's just keep this as equation 1 and this is equation 2. Okay, please write it down in your book, beta. Now what you're going to do is you're subtracting equation 1 and 2 and you will get X and you will put the value of X and Y and then you'll tell me the Y equation. Please write both of this equation. Okay, let's just not make it a big deal here. Let's keep this as equation 2. ये बड़ा हो जाएगा. While solving here, you do it, okay? Equation 2 is 6 square is equal to Y square plus 5 minus X whole square is equal to 2. Is equation 2, okay? This is equation 2, this is equation 1. This problem has nothing. It's just the Pythagoras theorem that you're going to prove because you're going to find the smallest thing here, right?
Yes.
So we are going to apply the Pythagoras theorem here. Come on, please. Understood?
Yes.
Have you written equation 1 and equation 2?
Yes. I can't see the equation 2.
Okay, 6 squared is equal to y squared plus 5 minus x whole square. This is equation 2.
Done.
Done. So what we are going to do is subtract 1 minus 2. You will get the value for x, then you will get the value for y. Can you do it now, Beta? Can you solve and find the value of x from this? Will you give it a try? Or should I do it for you? Should I do it? If you tell me yes, then I'll do it. Okay, I'll do it for you. Okay, equation 1 will be, let's just open up equation 1. It will be 25 is equal to x square plus y square, right, Beta? What will equation 2 be? 36 is equal to 5 minus x whole square plus y square. Let this be. Okay, let's just subtract 2 minus 1 because 36 is greater than 25, right? 2 minus 1. So 36 minus 25 is equal to 5 minus x square plus y square minus x square plus y square मतलब क्या होगा? x square minus y square हो जाएगा, right?
Yes.
Right, beta? So y square and y square cancels out. Why is it? Plus and minus cancels out. What is remaining? Minus x square remaining. So what is 36 minus 25? What is 36 minus 25?
11.
11. Very good. Okay, it's 11. And what is 5 minus x whole square? Please do the identity and please tell me the answer. Is it not 25 minus 2 into AB? What is 10x plus x square? Yes, it is this one. 25 minus 10x plus x square. And बाहर एक और minus x square है आपके पास, correct? X square plus x square minus x square gets cancelled out, right, beta?
Yes.
Yes. So what it will become? What will you do now? 25 you will drag this side. Can you see the screen which is written below now?
No.
No. Okay, I'll write it here. 11 is equal to 25 minus 10x plus x square minus x square is outside, correct? This is the splitting the identity, correct? A square, a minus b whole square is equal to a square minus 2ab plus b square. Fine. X square minus x square is cancelled out. So 25 minus 10x is 11. 11 is equal to 25 minus 10x. How will you find this? What do you have to find now? The value of x. What you will do? 11 minus 25 is equal to minus 10x. What is 11 minus 25, beta? 25 minus 11 is the same. What is 25 minus 11?
14.
Is it 14? Yes. 14 is equal to 10x. Minus minus cancels out, okay? Here it will be minus, here it will minus, it will cancel out, correct? Yes. So 14 over 10 is equal to x. So can we just simplify it? 2 how many times is 14? 2 7 times is 14. 2 5 times is 10. So x is equal to 7 over 5. This is your answer. X is equal to 7 over 5. So how will you find y now? X is equal to 7 over 5. Y is very easy. You just have to apply x is equal to 7 over 5 in any equation. 7 over 5. Have you written it down? Whatever I've written in the previous thing? Yes? Yes or no?
Yes.
Okay. X is equal to 7 over 5. How will you find y? Just apply this in any equation, beta. Please apply this in equation 1 or equation 2 and find the value of y. I'll just give you, you're going to solve the rest of this problem, okay? We are actually very much time today. Okay. Can you please find the rest of this and give me as a homework? There are 2 homeworks for today's class. Homework for number 1, continue this problem. Tell me the answer to y. Okay? What is the answer to y? And if you find y, if this is y, you have to just write 2 times the y. Okay?
Yes.
Yes, this will be AC. This is done. Then I remember you have given another homework. What was another homework? Do you remember something? I had given you some. Question. Which question, beta?
First question.
Yes, first one, please. First one and fifth one, there's a homework for you. Fifth one is very easy. We have found x. What is x? Apply it in x and tell me the answer, okay? So let's just summarize. We have studied 6 theorems and we have studied almost 5 questions. And the 6th one, the same as 5th one. Let's do it in tomorrow's class, okay? Inshallah. So any doubts till now, whatever we have studied?
No.
No doubts, mashallah. So please do the homework and come